Hi everyone. In the previous lessons, we looked at the difference between main processes and sub-processes. We explored some types of palettes that essentially perform a series of activities, including those designed as the starting point of a process, timer, and others with specific purposes, like the mapper. We also saw how the flow follows palettes and transitions, and how the latter can branch the execution flow. In this lesson, we'll analyze another type of palette, groups. Let's start by making the exercise from the last lesson more complex. We will no longer accept a single operation as input, but multiple operations simultaneously, with the goal of obtaining the results of all these operations. First, let's modify the input and output schema. Let's define a more appropriate name and create new input and output elements that refer to the ones created previously, but increasing their cardinality from 1 to n. We can refer to an existing element using the ref attribute and inserting the declared namespace prefix, in this case TNS. The created subprocess immediately shows some errors. So let's define the input and output that have now been modified. The plus symbol indicates that the cardinality ranges from 1 to n. We connect the mapper to the single output element. We will see two ways to perform iterations. Let's start with groups. A group is nothing more than a designated area for the execution of a flow, and it can contain one or more palettes. Today we will look at iterative groups. Right-click, Create Group, and choose ForEach. We will have an index variable, which we can rename, and which keeps track of the iteration counter. This variable is present in every iterative group. All the iterative group requires an initial index which, in TIBCO, as in the XML world, starts from 1. So, as the final counter, we insert the count of the input operations. We log the index with an initial log palette inside the group. With ForEach, we need to execute the logic based on the indices. Let's create a variable in the mapper's XSLT to refer to the element with the current index, so we don't have to repeat it every time. The index variable is visible in all palettes within the group. Then we rewrite the same logic seen in the other lessons. In the otherwise, we insert a not found message for the operation. In the division, we insert the logic in case opus 2 is 0. An important step to perform, so that the mapper does not return a single element, is to select Accumulate Output in the group, indicating the mapper as the output activity. In this way, in any palette after the group, we will see the multiple accumulate element, which we can copy to the end. Let's insert multiple operations in the test, which must be at least one. Let's do some tests by launching the debug. Please support us by liking the video and subscribing to the channel. Another group is the repeat, similar to while, with the difference that the iteration will be repeated until the condition is no longer met, so as long as the index is greater than the count. Here we also see the palettes inside the group, so it can also function as a do-repeat or do-while. Let's save and press the icon that removes the old processes from the debug. Let's modify with while by changing the condition so that the iteration is repeated as long as the condition is met, so as long as the index is less than or equal to the count. On the left side, in the Jobs section, we can see how many times the while has been executed, as well as the input and output of the palette. Another group is the iterate, which iterates over repetitive elements. So let's choose the element to iterate over. As input to the palettes inside the group, we will see the current element variable, which refers to the current element. So we use that instead of choosing based on the index. The result is the same. Another type of group is repeat on error. This repeats the execution flow within it if an exception is raised. It is useful for interacting with a database or for calls to web services, as they may have busy connections or other issues. When the stop repeating condition is met, there will be no new iterations. Let's insert equal to 4. We insert the condition for which the index, which we remember starts from 1, will be equal to 4. Let's add the repeat on error to the mapper and remove the logic that avoids division by 0, which is already inserted in the main. Let's save to start the debug. The loop is similar to a do-while. It evaluates the condition before iterating again. In fact, we can see that the loop is executed 4 times, after which it raises the exception to the parent process. There is another faster and smarter way to iterate over elements, which however cannot always be used, the ForEach that XSLT provides. Let's copy the process and paste it, naming it Smart Math Logic. In this case, let's remove the mapper from the group and set the multiple output element on the mapper. Right-click on the multiple element and select ForEach. Let's drag the multiple element that comes from the input onto the ForEach and rewrite our logic. TIBCO automatically understands the iteration and does not ask us for filters on the elements. Let's delete the previous element and fix the inputs of the log palette and the end of the main. By launching the test, changing the process reference, we will see that the result is the same. As an exercise, your task is to add 2 optional integer inputs to the subprocess, min and max. If neither input is provided, the normal flow executes. If only min is present, operations from the min index to the end should be performed. If only max is present, operations from the initial index up to max should be performed. Finally, if both are present, perform operations from the min index to the max index. Thanks for your attention. For any questions, feel free to comment below. If you enjoyed this video, please like it and subscribe to the channel.